Hello everyone, welcome to the channel LeetCode, and in today's video we will discuss LeetCode weekly contest 325 question number of great partitions. So here we are given an integer array nums that contains only positive integer and one another integer k. Now we are asked to divide this array into two groups in such a way that sum of all the numbers in both the group must be greater than or equal to k, and we need to find number of distinct partitions possible. Okay, and yeah, the number of partitions can be large, so return the answer with this modulo. And the two partitions are considered distinct if some elements of num1 is in different groups in the two partition. That means if the numbers are different, then we can consider the partition as different. Okay, so let us look at the first test case given. Here we are given the numbers 1, 2, 3, 4, and these are the 6 ways we can partition this 1, 2, 3, 4 to get the sum of numbers greater than or equal to 4. So here also the sum is, let's say, 3 5 plus 2 5 plus 1 6, that's greater than or equal to 4. Here 4. Okay, so that way they have given us 6 different combination possible. In this next test case, there is no such combination possible with both the groups having sum greater than 4. So in one group we can either put the 6 value, or in other group it will be only 3. So there is no such partition possible with the sum greater than or equal to k. Here in the third example, both the numbers are greater than k and we have only two numbers, so the total partitions is 2. So let us now take a bit closer look to this problem. So here let me take one example. We are given some numbers like 1, 3, 6, 7, 8, and let us assume that k is 12. So here we need to form partition 1, partition 2. So we have choices like either to include 1 in partition 1 or 2. Let's say we included 1 here. Then further we have two choices to include either 3 in partition 1 or 2. For an example, assume that we included that 3 in the partition 2. Similarly, for each number we have some of the choices where to include the numbers either in partition 1 or partition 2. So whenever you see the choices like this, like let's say choice C1 or choice C2, we can think of recursion. Okay, so here as also we are so here as we have choices like to take the numbers either in partition 1 or in partition 2, so we can definitely think of recursion. So and further recursion code, we can also memorize this recursion, so that will become our DP. So how we would do this recursion is, first thing we would take one int sum variable to store the current sum. So if this sum is greater than equal to k, and if the total sum that is total sum of all, that is sum of all numbers, that is total sum minus this sum is also greater than equal to k, that means we can form the sum partition p1 with this sum and another partition p2 with this. If both the partition has sum greater than k, then this is one possible answer. So we need to find number of such possible partition. Number of such possible partition. Okay, so this is one thing we can do here. Okay, so this is the code of the approach that we discussed right now. So here this is the solve function, a recursive function that I have called is 2 times, and here this is the total sum, and here is the s1 or the current sum. So and when we reach till the end of the array and we check if s1 is greater than k and then total minus s1, that is the numbers present in partition 2 are also greater than k, then we return 1 as we return 0. So this is one of the approach that we do by using recursion and memorization to solve this problem. But if you try to submit this won't work, as the total number of nums length is 1000, and this will give you wrong answer. So this won't work, as this will give you a TLE, time limit exceeded error, because you are trying to find all the possible partition here. But there is one another better approach to solve this question, and let us look at that. So here, instead of finding number of partition P1 and number of partition P2, what we can do is, total number of subsets possible is to the 2 to the power n. So for an array of size n, the total number of possible partition is 2 to the power n. Okay, so the next thing here is, if we somehow know how many partition are wrong partition, that is a wrong partition, or the partition containing elements whose sum is less than k. So if we find the number of that partition, we can simply, what we can do is, we can simply subtract it minus total number of partition. So this is an efficient approach to solve this question, where we would this calculation is simpler, and this calculation will take less than, so our time complexity will be reduced here in this case. And approaching this problem would be same, as we would first write recursive code, then we will use memoization by taking 2D DP. So that approach would be the same. The only thing difference here would be, we instead of finding both the partition, we would simply find the number of wrong partition and simply minus it or subtract it from total number of partition. Okay, so now let's look at the code here. Let me try to clear this. Okay, first, if we will look at the total sum of all the elements present in the num side m, and if total sum divided by 2 is less than k, we would simply return 0, because no such partition is possible here in this case. Else we would find number of wrong partition. Now let me define one long variable, ll is long. So we will use ll throughout our code. And we would call this solve function here. We will pass nums k and one current sum, that is 0, and 1 0 for the I index. Let us take a look here. Let me also initialize one modulo variable, that is 10 to the power 9 plus 7. Let me take now code this solve function. I will input this vector nums, then int k, int, let me take index idx, and let me take long sum. Okay, now if index equals to nums dot size, that we have reached the end of our array, and if sum is less than k, we would simply return 1. That means we have found one wrong partition, else we would return 0. Further, what we would do if sum plus nums of I and nums of index is less than k, then we can add that. So this is one approach. Let me initialize two variable, count1 equal to 0, count2 equals to 0. So instead of counter, you can see this choice1 and choice2. Yeah, the choice1, what we are doing is, we are taking we are including this index number num into the sum. So that is sol nums k index plus 1 and sum plus nums of index. In the else situation, that is choice 2, it would be simply moving forward and not including that number in our sum, right? And here we would return choice 1 plus choice 2. Okay, now the another thing we would try to calculate is total subset for a given array. Let me initialize this one because an array is itself a subset. Now for integer I equals to 2 and I is less than equals to, now dot size I plus plus, we would do total subset equals to total subset into 2. So this is simply here what we are doing is 2 to the power of size of array, size of nums, you can say. This many times we are multiplying total subset by 2. Instead of 2 it would be 1 here. Yeah, and further our result would be total subset minus wrong partition. Okay, and we would return our result variable. Okay, and further to optimize, we will take one dp of the same size 1001, and yeah, if dp of, let's say, index and sum is not equals to -1, that means we have pre-computed this value somewhere before in time, then we would simply return that. As in the, and further we would store our answer here also, store this value of dp here equals to choice 1 plus choice 2. We would also now do modulus at necessary places to avoid integer overflow situation. So here also modulus of 2. Okay, now and further before returning also I will do modulus of 2, and if result is less than 0, that means we have found a negative, then we will simply add the modulus just to overcome that integer overflow situation. Now let me try to run this code. Okay, something we are doing wrong here. 16. Yeah, one thing here we forgot is initializing this dp array. So let me do that now. Mim set dp -1 size of dp, and now let me try to run this. Okay, so the one thing to note here is, let's say 1 2 is wrong partition. So similarly way it can be either way. Means this can be partition 1, for example. If our partition is 1 comma 2, then the same partition can be for partition 2 also. Partition 2 can be also 1 comma 2, and both are different thing. So for each wrong partition, what we have to do is multiply 2 times. That's because the wrong partition can be either in the partition 1 or either in the partition 2. So that's the case here. Now let us try to run it again. Okay, now let me try to submit this. So integer overflow. Okay, let me now make it total sum plus n and do modulo here. Okay, now let me try to submit this. So yeah, it got accepted. So there were a few things that to note down here. First thing was we found the wrong partition and subtracted that from the total number of partition or total subset possible. Further, the wrong partition can be in the partition 1 or same can be a part of partition 2. So we need to multiply total wrong partition into 2. And this was pretty much recursive plus memorize code. So I hope you got the solution and you understood the question well. Thank you. So that's all for this video. I hope you guys liked the video, and if you have any doubts, let me know in the comment section below. Make sure you like the video and subscribe to our channel. Thank you.